How's it going, everybody? My name is James. You can also call me Striper with New England Science and Sailing. Today, we are talking about one of my favorite lessons to teach, and that is density dynamics. Now, in this lesson, when we're teaching it, we really try to focus on a couple of main objectives for our students. So when you're teaching it, really emphasize that they are investigating the relationship between salinity, temperature, and density, and then observing those changes in density using buoyancy as that metric. Now, the reason that this is one of my favorite lessons to teach is because this lesson can take you 15 minutes if you would like. It could take you 3 hours if you would like. It's really all about you and your students and how much differentiation you really want to use, how much leeway you want to use, how much you want to give them those context clues, and how much time that you have with your students. When you are doing this lesson, at the start, you want your density layer already set up. So right now we're going to talk about how do we actually set that and those layers up. Now, for this experiment, we have 2 cups of water. We have 1 warm, fresh water. And then, very similar to our oceans, you have that cold, salty water. Mix as much salt as you would like. Doesn't matter if it's all homogenized into that water, just that it is salty and cold. The bigger spread, the bigger differences you can make, the easier it is to operate and run this experiment. So you have those 2 cups of water, and then the goal for this, really getting those layers and seeing how density interacts, you then get your objects to test. Now, in this lesson, you really want one that sinks all the way to the bottom, one that floats all the way to the top, and then one that does what we like to call a NESS, flinks. Doesn't flink, or it doesn't sink, doesn't float. Kind of stays right in the middle, neutral buoyancy, it flinks, right? So, pro tip, when you have your setup, you have your sediment tube here attached to your arm. The 2 biggest pro tips I can give you. 1, a cup to catch all the water underneath. Yes, there is a clamp down here. You can trust it as you would like to. I always like to add that little extra layer, something underneath to catch, just so that it kind of controls the amount of mess in the event that it does leak. And then 2, the biggest one. When a lot of people are teaching this lesson, and what you'll find is a lot of times your students are going through this lesson, they'll make their water and they'll make those different densities and they pour the water in the tube before checking, do their objects behave the way that they're supposed to. The biggest pro tip that I can give you is before your students get in the room, when you're building this experiment, take your objects and test them in the cups first. That's going to make it a lot easier, and you hopefully won't end up having like your 6th and 7th failed attempt that was supposed to flank and it ended up going all the way to the bottom. I know you got to retrieve it. So you should have one object that sinks in both the cold, salty water and the warm, fresh water. Perfect. You should also have one that floats in both the cold, salty water and the warm, fresh water. Beautiful. And then the tricky one to get right, as you're building these objects, you're adding the clay to the straws, is the one that flinks. That might take you a couple of more minutes. So the goal is to get this one to float in your cold, salty water and sink in your warm, fresh water, right? So when you get those 3, grab your water as you're ready to have it put into the tube. Take your cold, salty water first and start pouring it in. Now again, I told you that this lesson can take 15 minutes, it can take 3 hours, right? So if you had a lot less time, you want to give your students more context clues to help them along the process, you can use cold blue water and warm red fresh water, right? To just give that subtle reminder, that subtle context clue of what they're looking for. If you have a lot longer, you really want your students to focus on problem solving, fake them out a little bit. Use yellow, use green, use different colors so that they don't get that context clue right away. So as you're pouring that cold, salty water into the tube, make sure you get it all the way in. And then the tricky one is that warm fresh water. Now, I like to really try and get surface tension to help me as much as possible. So when I pour this in, I like to go right along the edge so that it just gently layers on top. And what you should start to notice as you pour that warm fresh water in is you really should start being able to identify those different density layers. So you still have that cool, cold, salty water on the bottom. It starts to mix kind of right in between, so you start to get, in this case, yellow and blue. We get green in the middle. And then as we pour all of it in, we start to get blue right up top. All right, so here we have our density layers ready to go. So again, we have very reminiscent of our oceans. We have that cool, cold, salty water on the bottom, warm, fresh water running off of our coast, and then right here we get that mixing in between, that brackish water, where you get the mixing of that fresh and salt water. So here's the trick. You have your one that sinks all the way to the bottom. You have your one that floats right at the top, and then you have your one that flinks, and it should get suspended right there, right in between, and that's the one that's going to blow your students' minds. When they walk into the room and they see all three, game over. You got them hooked. They're going to be ready to learn and experiment with density as much as they possibly can. Thanks for hanging out with me. Hope you enjoy this lesson. See you soon.